Thank you, everyone. And thanks to Ronghua. He got me thinking a lot when I was waiting there, and I forgot all about what I want to tell you. So instead, what I will do is I'll tell some stories instead, and forget about the technical stuff. Okay, so there is an outline. Oof. Right, so I'll follow the outline. I'll tell you some stories about digital twin, how it evolves from a physical twin to a digital one. And then I think the gist of it is how do we apply it in a smart city context. And moving forward, how do you build one? What are the tools available? And then what are the use cases? So what is a digital twin? A twin is, two person or two objects looking alike. And when one moves, the other one moves as well, right? So a digital twin is an integration between the physical and the virtual object mimicking each other. So when one moves, the other one also moves. And if you are familiar with digital twin, please stay with me. Whereas for those not familiar, I'll go a little bit deeper. So the history of digital twin goes more than 2,000 years back. The first one is actually a physical twin. That's an entire cathedral. They found it off a coast in Mediterranean Sea, Greece, 2,000 over years ago. It sunk there. People think it's an alien object. It's a technology that was developed by aliens. But only recently they discovered that it is actually a physical twin. What it does is that it's a hand crank. When you crank, you are able to see the trajectory of the Earth revolving around the sun and the moon around the Earth. In fact, they think that there might be 5 other planets that is on this device. And that is probably the first physical twin that mimics the real world. Subsequently, the tech disappeared for 1,500 years because that thing sunk into the sea, so people lost the tech. And this guy called Copernicus, he's a Polish, 1,500 years later, then he made an announcement that the Earth revolves around the sun, and then he's called a heresy. He's a heretic. And moving forward to 1960s, that's when NASA starts to build physical twin and digital twin for the Apollo missions. So if you have watched Apollo 13, anyone of you watched the movie Apollo 13? Yeah, okay. So Apollo 13 got into a lot of trouble, right? The engine failed, and that module failed, this module failed. How does NASA bring that 3 astronauts back? Actually, they have another replica of the spacecraft on the planet. So what happened is that they mimic a couple of scenarios, and then they try on the twin, and then they tell the astronaut on the spacecraft to follow. And that's how they get themselves out of trouble and make their way back safe to Earth. So that's the power of the twin. And moving forward towards 2000, and that's when people like Rolls-Royce starts to create asset twins that mimic their engine. Because engines are such expensive assets. When you have someone, like what Ronghua said, right? Code got vulnerabilities, and then anyhow code, the code doesn't work, and then you spoil the engine. What happened? Millions of dollars get burnt. So instead, what we do is that we create digital twins. And I will give you a demo later on how GovTech use digital twins to solve problems. So they build digital twins whereby people will test their source codes, test their algorithm, test their concept before they actually apply it on the real stuff, right? And today, at the present, which is the main topic of my presentation, is about how to use digital twin for smart city application. So again, then this goes back to the Apollo mission, the first digital twin, and these are the things that they are trying to resolve. It must be realistic. It must be connected. Connected as in it's connected to sensors, connected to control systems. It must be data-driven. It means the data is driving the outcomes. And then it's adaptable and threaded as in like it's weaved into the various workflow and then executed. Must be able to execute simultaneously, and it's responsive. Moving forward, we can see that because of this property of the cyber and the physical integration, you can see that a digital twin can be used as an asset twin. which I mentioned just now, like the jet engine. The jet engine is an expensive asset. When you use the digital twin for on an expensive asset, you can actually test out a lot of the concepts, a lot of the algorithms that you want to test. Otherwise, if you don't have a twin, you have to test it on a physical object. And the physical object may fail as a result of some of the mistakes that we make. A system twin is something more complex, right? So instead of just an asset, when you string all the system together, you actually can test out some of this integration, and so on and so forth. And moving into smart city, at the building level, whether it's a lift system, whether it's an aircon system, whether it's a building management system, the car park system, that's where a digital twin can be useful when you want to test out certain scenarios, especially in the state whereby we want to push for sustainability. You want to know if you increase the temperature by 1 degree Celsius, what's the thermodynamics outcome within the building? You can simulate that before you actually make everybody sweat it out to find out that it's actually not very comfortable, but you can actually test it out in the digital twin. Or what you could do is that you reduce certain energy consumption, and then you want to see how does it affect the human flow. All this you can simulate it within the virtual environment. And when you go even bigger at the city level, that's when transport system, that's when residential, estate, municipal system, energy system, water systems can be tested, right? And then I will show you a video demonstration of how a digital twin can be useful in that scenario. But before we move on, you can see that there's actually 5 levels of digital twin that I'm trying to articulate here. And this is borrowed from Autodesk. Autodesk defined digital twin into 5 levels. The level 1 digital twin is actually just a visual replica. Is a visual replica useful? Some people may think, not so useful, it's static. Actually, no. Because a level 1 digital twin, even though it is not connected to the physical world, it is, after all, an exact representation of the physical world or a physical object. So what you can do is you can actually visualize it and play with it. And if it's a building or a city or maybe a product, you can actually use it for marketing purpose. It can be immensely powerful, especially the real estate agents. If you go and visit some of these condominium showroom, you can actually see your apartment before you actually buy it, right? So actually that's the utilization of a level 1 digital twin. Level 2 digital twin is informative. So this is when you connect real-time sensor data into that digital twin. And whatever happens in the real world, it is represented in the virtual world. It is useful for analytics purpose, for ops planning, for design purpose. And then as you move up some more, you have predictive twin. So what does the predictive twin deliver? It gives you the ability to do simulation, identify problems, right? And if you go further up some more into a level 4, which is a comprehensive twin, advanced modeling and simulation can come in. Just now I talked about computational fluid simulation, right? CFD, right? And then you can also mimic physics engine. You can mimic clash of objects. You can mimic route planning. So this is when a highly capable digital twin comes into play. And this is also the kind of digital twin that can actually deliver a lot of cost savings before you actually apply some of the concepts that you want to do that is not tested in the real world, but you can run it on the digital world. The last one, within my team, we often joke that autonomous twin is something where you can actually shut down the computer screen, you let the digital twin run the show. Because the AI within the digital twin will control all the systems and give you the outcome that you want. That kind of make us obsolete. Okay, of course, that's the final outcome that a lot of the digital twin products out there wants to achieve. I've not seen anyone that achieved level 5. Within GovTech, some of the agencies that we support, like for example, JTC and LTA, we are somewhere around 2.5 or to level 3, right? So then you may ask, how do I build a digital twin for smart city? So the first thing we need to ask ourselves is, what kind of systems do you want to link up within a smart city? Is it a full-fledged smart city whereby every single domain from mobility to education to residential to healthcare, do you want to bring all this data in together? If the answer is yes, then you need a very powerful framework where you unify all these systems together. That is not just a digital twin per se. It's an entire stack of technology that you need to put in place, like cybersecurity, sensors, IoT, software, right? Systems. You have to bring everything together. And that kinds of allow all the system to come into one place. Then you can build an application like a digital twin, where it can represent some of these systems. And if you were to look at it, you need a lot of support from government agencies, because a lot of these systems are managed by different government agencies. There are also private entities, big MNCs who have campus. So it's the same. You need to get all the departments to come together, work together, connect your system together. Then you can build a powerful digital twin that is representing the entire operations within your organization. But if you were to, again, move back to the smart city aspect, and then you say, okay, now, yes, I spend millions of dollars connecting all these systems, and then, yes, I got someone to build a digital twin. But what's the use case? So we talked about modeling and simulation to deliver the outcome, to test out the outcome, to test out the concept. So modeling and simulation is one of the major KPI or objective of a digital twin. The next one is resource planning. Because if you have all these assets visualized in the real world, with all this data coming into the real world, you will be able to test out certain resource allocation. Like for example, if I build more buildings here, I build more car parks here, how does it affect the traffic flow? You can actually run simulation on it. And the resource planning is pretty powerful, especially if it's energy related, for example, transport related, human flow. The other one is a command and control system. Traditionally, if you go into a facility management command center, you either see a bunch of panels here and there, and then you have a 2D dashboard. I think in those days, it's fairly useful. But in the modern world, when we are talking about efficiency, talking about optimization, talking about reduced costs, this is where the 3D command center comes into place. With a three-dimensional command and control system, right? In fact, in the manifestation of a digital twin, you can put less people on the ground, because these people don't need to go and inspect everything within the building or within the facility or within a system. They can all do it within a digital twin, you know, in the comfort of the command center or at the comfort at your desk. Again, anyone have seen a movie Starship? Nobody watch movie one here. Okay, if you watch Starship, right, it's a sci-fi movie, it's a romance story, there's no aliens to fight. But that Starship is very intelligent. When it's hit by an asteroid, it's able to tell people that which component has failed, and downstream what other components will fail. And that is when a three-dimensional system is very useful for you to visualize some of these problems. Okay, next comes marketing. I talked about marketing. Marketing is very useful. You can show the sun ray simulation, tell your potential customer, say, hey, this unit is very good because it has no afternoon sun. Or you can show your Ferrari, you know, wow, this color, that color. That's useful. I don't need to say more. Other stuff is that it's for you to track objects. If the object is moving, you want to know where it is, you don't have to keep following the object or turn on a CCTV. You just have to go to the 3D world and find your asset. So a good one is, for example, robots. You know, within a robot, you want to find where a robot, go to a digital twin, find the robot, and know where it is. Okay. So how do we build digital twin quickly? Or how do you build one on your own? I think one way is you invest a lot of money, you build your own 3D engine. But let's not go there, right? That's immensely difficult. But how do you do it quickly? There's actually a lot of product out there in the world today. Like, for example, if you are looking at geospatial kind of digital twin. You have ArcGIS up there. I think a lot of you have heard about ArcGIS. You have CCM, all right? And then the data format, one of them is CTGML. And that's where you're able to put in the geospatial layer into a 3D engine, and then you visualize it. And this engine usually are this geospatial engine. And then if you want to do a building engine, building digital twin, you can use Autodesk products, like for example, Revit, or you can use 3ds Max, you can use Rhino, and then the format, of course, BIM format, IFC. IFC and BIM allows you to build digital twin very quickly because they are accurately represented in the digital world. And then if you spend some time to texture them, you bake the lightings, they can look as real as the real thing. And you know, these days, GPUs are very powerful. If you turn on ray tracing, they can really look very, very realistic. At the other side of the slide, you can see we have game engines at the bottom. Actually, we call them real-time 3D engines. So like Unreal and Unity. If you're familiar with game engines, there's no need to illustrate more. These are the platform where you can actually use to develop and customize the digital twin that you want. And the last one is platforms. So these are the new kid on the block. People like AWS, people like NVIDIA recently has been talking to us. They have platforms that are agnostic to other platforms. You know, you can pipe connections to them, and you can build digital twin, lifelike digital twin, and they are connected. So if you have interest, either Google them or maybe you can catch up later. So the next one is more about the framework of a digital twin. So after you choose a platform that you want to build, what are the other considerations that you need to think about? Moving from the front end. The front end UI is important. Because even whether you use ArcGIS, or whether you use CCM, or whether you use Unity or Unreal, or you use Omniverse from NVIDIA, you need to think of how you want to create the front-end interface. In fact, a lot of it is 3D, the 3D rendering. Whether this is a lightweight digital twin, or this is something very immersive, very heavy. Moving towards the core, you need to think about the AI and the machine learning algorithms that you want to put in place. Are you going to do a human flow? Are you going to simulate the physics engine? Right? You need to find a model that is pluggable into the platform that you have selected. Next comes the information architecture. How this information comes in, whether it's a geospatial one, like whether you are using a WGS 84 coordinates, whether you're using a simple Cartesian XYZ coordinate system, that you need to decide. And then you need to find out whether you want to build in search engine to find objects, to find assets within the digital twin. And for example, you might also want to define zones. Zones whereby there are certain things, certain area you want to put what kind of objects. Is this something for show only? Maybe no need to focus so much time, but this is the zone where you want to focus the centerpiece of your digital twin. That's where you need to spend more time, right? And data handling is one of the most important component within the digital twin, because the digital twin is not just 3D, right? It's also about data ingestion. With all this data coming in, so many data coming from different sensors, different assets, you need to have a very powerful data handler. If you will just use the platform out of the box, you might very fast discover that it cannot scale. And then when you pipe more and more info, the system just becomes slower and slower. So you need to have a strategy to handle your data. And hence, there might be a need for you to consider using a middleware. A middleware that converts all this information into a standardized data model, and then that's something that's easily visualized in the digital twin. And then you also need to define the data source right at the edge, whether it's what kind of capability you want to bring into the digital world. Is it just sensors or a control system? Or do you want to let people manipulate it, or you just want to visualize it? So those are things that you want to consider before building a digital twin. So there is a framework that you can follow. right? So these are the layers: data management, system and network. How do you want to build a network to connect up the systems, right? And then in terms of the asset, whether it's a building, whether it's a product, whether it's at the city level, you need to consider what are the systems that you want to bring in. And the UI is important because a lot of the user interface in the 3D world is very different in the 2D world. You can very easily lose your user if you don't design the UI properly, right? And of course, to a larger extent, the navigation and control, right? So a lot of us, those are the guys, or even the girls, if you play games, the typical WAS, those kind of keyboard controls and all this, you may want to consider using them because it actually is fairly intuitive. But if you want to develop something more customized, then you need to know how difficult it is that your user can use. All right? Before I go into a video demo, but what I wanted to say that is later in these two videos, there's two digital twins. One is a asset twin, which in GovTech, Sensors and IoT, my Sensor and IoT team, we're starting to develop this digital twin whereby we allow programmers to mimic our robotic arm in the physical world and connect it into the cyber world. So what's the benefit of this? One is we can actually simulate the movement of the robotics arm, and then we can try out some of our algorithm without using the real thing. Especially in the day where, in these days, where some people work from home. We cannot afford bringing all the robotics arm home for every single engineer. But if you have a digital twin, the control interface to every single stepper motor, servo, controllers are defined the same, then you can actually let the engineers work from home because they can actually do their work on the digital twin without having access to the physical world, right? And the last demo is about how we implement a smart city digital twin for Punggol Digital District. So a lot of work has been done and they are real. Later, the video demo will give you a taste of what it will look like. Without further ado, let me show you the asset twin. So this is a robotic arm. Maybe I'll click one more time. This particular robotics arm, we use it to test certain of our control algorithm. Later on, what you will see is that one of my colleagues will start to move the robotics arm. And you can see the virtual world, the virtual robotics arm is also moving. So basically, what we did is that we have mapped the coordinates of the digital twin, within the digital twin, into the orientation of the servo and stepper motor within the robotics arm. The next step to develop this digital twin is to define the system interface to every single servo, every single stepper motor, the controllers, and we control, and we will then be able to write codes and mimic them in the digital world, right? And then, of course, vice versa. The digital world can then influence the physical world and control it. So that's when the asset digital twin becomes very useful. Next one, I will go into the smart city demo.
Open Digital Platform, a district management system that enables efficient management of multiple estates across Singapore. The platform converts and displays sensor, geospatial and building data on an integrated 3D platform. In the country overview, enable map overlays of weather data, sensor data, and transport, aircraft and maritime vessel data. Capture open data from government agencies and display useful data geographically. Receive automated notifications according to preset limits. Sent via system alerts or an instant messaging platform. Estate managers can easily navigate across the various estates highlighted. The Estate Command and Control interface provides estate managers real-time updates on estate operations, such as power and water consumption and electricity loads. In the building overview, visualize geographical positions of systems and assets across various building levels and zones in real time. Enable responsive maintenance with the help of real-time incident reports from the digital twin. Assign tasks to the nearest available staff to carry out maintenance and attend to incidents. The JTC Summit, a 32-story, 450,000 square foot building constructed in 2000. Building floor plans are painstakingly converted from CAD to BIM and meticulously textured in 3D to create a lifelike digital replica of the building. The open digital platform allows for seamless plug-and-play integration with existing building systems. Monitor and manage systems such as district cooling and smart grid, car parks, human flow monitoring, fleet management, and urban logistics. Measure efficiency and load distribution with the help of charts and data analytics, allowing for more efficient resource allocation and management. Automate interactions between systems and repetitive processes such as mail and package deliveries. Model real-world conditions within the platform. Simulate events over the last 24 hours using real-world historical data in playback mode. Simulate emergency situations to plan emergency response procedures and train staff to respond quickly in a real event.
So, basically what you see in the last video for the Smart City Digital Twin that we have implemented with JDC, a very powerful feature is a historical playback. So if you are able to load the time and the day that you want to investigate of a particular event, the digital twin can do that playback for you. You don't have to hunt through the CCTV to find out where the problems. In fact, the CCTV might not give you all the solutions. The digital twin is highly likely to be able to do it if you implement your twin properly. So with that, I end my presentation. Right? Thank you, everyone.